Okay folks, we're going to continue to look at Pythagoras this week, this time in 3 dimensions. Before we do that though, I think there's one last case of the 2D theorem that I want to make sure we've seen. We obviously went through this a lot last week in terms of, okay, side squared and side squared is height squared, and we generally said if any triangle is right angled then that must be true. Now interestingly, the opposite is also true. If the theorem works, then the triangle must be right angled, and you can occasionally get asked this. So here's 2 examples. Which of these are right angled? We're assuming they're not drawn evenly. We're also going to assume that these are the hypotenuses because they're the longest sides, and if those are the hypotenuse, they must be opposite the right angles. So let's see if the formula actually works. Well, in this first one, side squared, so that's 7 squared, other side squared, 7 squared, and we're going to say, is that equal to 10 squared? Well, this side is 98, this side is 100. It's not true, so we can say this is not right angled. The other triangle, well, again, let's try it. So let's see if 7.5 squared plus 10 squared is equal to 12.5 squared. That's 56.25 plus 100, and 12.5 squared is 156.25, and that works. So this is right angled. So yeah, if you get asked to analyze if a triangle is right angled, you just need to apply the theorem and see if it works. But yeah, let's actually try and apply this in 3 dimensions. So I want to point out this cheap and cheerful version of the formula that works in 3 dimensions. Previously we've been looking at 2D and base and height, and they were at right angles, and that was fine. Here we can consider depth as well as our third sort of side, and the formula just sort of generalizes. Let's see how that applies to a cube here. We want to find AG, so that's going from A up to G, and if we want to get from A to G, we're going to have to go along here, we're going to have to go across here, and we're going to have to go up here. So our 3 sides, let me try that one more time, there we go. So our 3 sides are from A to B, which is 4, from B to C, which is 4 as well because it's a cube and all the sides are the same, and then from C to G, and all 3 of those sides are at right angles to each other. So what do we need to do? Well, side squared plus side squared plus side squared is height squared. Let's call this x that we're trying to find here. So x squared is 4 squared plus 4 squared plus 4 squared. Simple as that. If we add those all together, then we get 16 plus 16 plus 16, which is 48. And again, please notice that we're not doing like a cube root or anything, just because it's in 3D, it's still the square idea. So we're going to square root that 48, and we're going to get that the length of AG is 6.93 centimeters. Yeah, and that's all there is to it. So let's try and do the same thing for this cuboid. Want to find the distance from BG and B to H. Let's do BG first. So BG is just from here to here. It's well worth trying to draw this on your diagram. And that's actually just a standard 2-dimensional triangle, isn't it? Because we just need to go from B to C and then up from C to G. So BG, we'd go something like, okay, x squared is equal to 3 squared plus 4 squared. So x squared is equal to 25. So it's the square root of 25. X is 5 centimeters. So BG, fairly straightforward. But what about BH? Well, BH is going all the way from up here down to here. And that's going to be using 3 sides. We have to go all the way across from A to B. We have to go all the way up from A to E. And we have to go across from E to H. Now, for those side lengths, we've got 8 here. The height of this cuboid is 4. And the depth of this cuboid is 3. So we're going to be doing 8 squared, 4 squared, and 3 squared. So for BH, we're going to say that, let's call it Y this time, is equal to 8 squared plus 4 squared plus 3 squared. If we add those all up, we're going to get ourselves to 89. And so we take the square root of 89. Length of BH is 9.43. Now there are other ways of doing this where you first find a 2D triangle and then expand it to another 2D triangle, but I really like this as a shortcut and I'd encourage you to use it. Now the rule doesn't change after that, you just have to think about what are some ways I can get from A to B using turns at right angles. You may as well have a go at these first, but I'm going to assume you've paused and had done that. Let's go on to C. So we want to find the length RU. if I'm going from R to U, I'm going from R, across to S, across to T, up to U. I wouldn't want to go up this diagonal here because that's not at right angles. I want to make those 90-degree turns. So again, let's call that x. We've got x squared is 8 squared and 4 squared and 3 squared. Oh hey, that's the same as before. Gives us 89, and so x is the square root of 89, which is going to give us 9.43 again. That's it. What about the length g to j? Well, if we want to go from g to j, we start at g, we go across to f, we go across to e, and we go up to j. And so that's going to give us, in this case, let's call that y. That y squared is 10 squared, and 4 squared, and 5 squared. So y squared is 141. Square root that, and we'll get that y is 11.87 centimeters. Now, one slight variant of this is we can be given the hypotenuse and asked to find one of the missing sides. Let's look at this as an example. We want to find the distance from B to C, so that's this distance here. And we're given actually the hypotenuse this time. We're given FC is 16. And if we were going from C to F, we'd have to go from C to B, across to A, and then up to F. So how could we use that? Well, we can write out the formula again, except this time our unknown is a side. So we'll have something like 16 squared equals 6 squared plus 8 squared plus x squared. And then we'd have to obviously work those out. So we've got here 256 is equal to 36 plus 64 plus x squared. And what's different this time is we're going to have to subtract that 36 and that 64 from the 256. If we do that, we'll end up with 156 equals our x squared. If we square root that, we're going to get that the length of the side that we're after is 12.49 centimeters. So yeah, all that's different if you've got the hypotenuse is you're going to be doing a subtraction. So have a go at this one. And let's assume we're back. So we want to find two things this time. We want to find EG and we want to find EF. Let's do G first. So we're going across from there to there. And we've got our hypotenuse here, which is 20. So we want to go across from G to E, up to H, and then in towards, I don't know, let's call that I because it hasn't got a name. We'd set up our formula. So we'd go for EG, if that is our X. We've got 20 squared is equal to 15 squared plus 7 squared plus our X squared. Work that out. So 400 is 225 plus 49 plus x squared, and then subtract those from our 400. This will give us that our x squared is 126, so we just need to square root that, and we'll get ourselves to 11.22. I'm assuming centimeters, but it doesn't actually say on the question. Also got to find EF. Now EF is just the distance from E to F, obviously. That relies on the length FG and the length from E to H, E to G. So we've already worked out this length as being 11.22. We're going to have to use that. The length from G to F is 15. So now we've got a 2D triangle. We can say 11.22 squared plus 15 squared. Let's call this y. It's going to give us our y squared. That's going to equal 351 on the left-hand side. It's equal to our y squared, so we just need to square root that, and we're going to get that y is 18.73. Again, I'll assume centimeters. Now, there are obviously loads of ways that this can be applied with any three-dimensional shape, but we're just going to look at one specific application of it today, which is with pyramids. And we've got here our formula for the volume of a pyramid. We did that back in chapter 15, I think. A third times the base area times the height. We're given a square-based pyramid here, and we want to find its height and its volume. So let's have a look at how we do that. Well, let's write the height on first. The height is from V down to this point in the middle of the square. So to get to there, how are we going to use these distances? We know from A to V is 12. We only want to travel at right angles, so that's probably our hypotenuse here. V to, let's call this point M, I suppose. V to M, we want to go at right angles here, so let's go straight across to the line here, and then let's go straight across to our point A. So some of those lengths we know, some of them we don't. We don't obviously know the height, so we can maybe just call that X. Do we know the distance from M to this line here? Well, yeah, because it's half the length of the side, and this is a square base pyramid. So M to here is just 5. And then, likewise, across from there to there, that's going to be 5 as well. Remember, we're taking our half of our 10. So yeah, that should be good. We've got 12 squared, hypotenuse, is equal to 5 squared, and 5 squared, and our height squared. Let's work that out. So 144 is 25 plus 25 plus x squared. Let's subtract those from there. We'll end up with 94 is equal to x squared, and that's going to give us x is the square root of 94, which is 9.70 centimeters. That's our height. What about the volume? Well, for the volume, we want to use a third times the base area times the height. So we're going to go a third times the base area. Well, the base is a square, and it's a square which is a 10 by 10. So it's just going to be base times height for that. And then the height of the pyramid, we worked that out, is 9.7. If we multiply all of that together, we'll get that it's about 323.3 centimeters cubed. So yeah, it's all about just finding that path from the places you want to go to that just uses right angle turns. This is more or less the same sort of question. I'd recommend you have a go first. Let's assume we're there. So again, we want to find height. That's going to be from M to T. Let's call that Rx. We know from T to C is 218. That's our hypotenuse. And then to get to there, we're going to take a right angled turn here and a right angled turn here. I'm going to have to fill in some sides. So this is square again, which is good, and this is going to be halfway along, so that's 115. That's 115 as well for the same reasons, and yeah, that looks in place. So we can go 218 squared is 115 squared plus 115 squared plus x squared, which are going to give us this interesting combination of numbers. If we subtract those, our 13,000s from our 47,000, then we're going to end up with 21,074 is equal to our x squared. If we square root that, we're going to get the square root of 21,074 is 145, let's go one decimal place, 0.2 meters this time. So that's our height. For our volume, we want to do the same thing we did on the previous slide, which is to go a third times the base area, which is 230 times 230, times the height, which we worked out as being 145.2. And that's going to give us a fairly massive 2,560,360 meters cubed. Big pyramid.